This 2022 paper 1 question 6, we're told to differentiate this function with respect to x from first principles. So the way that we do that is there's a formula. I would encourage you to know where the formula comes from. It makes it easier to remember. But we have f of x plus h minus f of x all over h. The idea is that this is the change in the y values, which is the rise. This is the change in the x values, which is the run. So h is like our gap. And we want to see what happens as the run gets really close to 0. So as the gap gets close to 0, the 2 points get really close together, and we get the slope of the tangent. Okay, so again, I'd encourage looking at where that comes from. So f of x plus h, we need to know what that is. Well, that'll be 2 times x plus h, the whole thing squared, plus 4 times x plus h, which will be 2, and then we'll have x squared plus 2xh plus h squared, and we'll have plus 4x plus 4h, which is the same as 2x squared plus 4xh plus 2h squared plus 4x plus 4h. So that's what f of x plus h is, just because we will need to know that. So this will be equal to the limit as h goes to 0. And then f of x plus h, that's 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus, and then f of x is 2x squared plus 4x. So again, to do that, we just, f of x we're told, for f of x plus h, we replaced all the x's with x plus h. All divided by h. Then we still look at the limit as h goes to 0. It's important to write that at every step. So we have 2x squared minus 2x squared. They're gone. We have 4x here, or sorry, not that. We have 4x here minus 4x here. They're gone. So what we end up with, and we can factor out a h. I'm just doing a few steps at once. Of course, in the exam, you'd write them all out. So we can factor out a h, because it's nice, because it'll cancel out the h on the bottom. So we get the limit as h goes to 0 of 4x plus 2h plus 4, because we've cancelled out the h's now. So that's equal to 4x plus 4 times 0 plus 4. Because we're letting, so here I didn't write limit as h goes to 0, because we've let h go to 0. So here it is, it's 0. Well, it's very close to 0, but we're just writing it at 0. And we get 4x plus 4 then as our final answer. And you can check with the power rule. This will indeed be 4x plus 4, so we have done it correctly. Then we're told that a rectangle's area is expanding. So the area will be the length times the width. We're told that the width is x, and the length is 4 times the width. So that'll be 4x, so the area is going to be 4x squared. What's the rate of change of area of the rectangle with respect to its width when the area of the rectangle is 225? So here's how we could go about this. We want to find the rate of change as with respect to its width. So that's the change in area over the change in width, and that'll be equal to 8x. Now the problem with this equation is to figure out what dA dx is, we need to know what x is, but they tell us what the area is. So how can we figure out what x is? Well, we know that the area is 225, and we know that the area is also equal to 4x squared, so we can actually figure out what x is, and then we can sub it into here to figure out what dA dx is. So dividing both sides by 4, we can get 225 over 4 is x squared. And this means square rooting both sides, and x is positive, tells us that in the question. So x will be equal to 15 over 2, because you just square root the top and the bottom separately. That's a rule of square rooting fractions. So now we can figure out what dA dx is when the area is 225, x is 15 over 2. So what's the rate of change? It'll be 8 times whatever x is. And we know that x is 15 over 2. And when you do that, you will get 60. And now in terms of unit, the unit of area is centimeters squared. And the unit of x is centimeters because it's a width. So the unit is centimeters squared per centimeter. So the area is increasing at a rate of 60 centimeters squared for every centimeter that x increases by. Then we're given some information about a cubic, and we have to draw its derivative. So basically, we're told that the maximum value is 1, p prime of 0 is minus 3. So if we're graphing p prime, well, we know when x is 0, p prime is minus 3. So here is one point that we'll have to draw. Are we told anything else? Not really. Okay, well, we know that when the derivative is 0, so we can put here, we have 0, and here we also have 0, because the slope is 0 at these points. We know that here is going to be the maximum slope, because this is directly in between the minimum and the maximum, so this is the area of the highest slope, because if you think about it, here the slope is getting steeper, and then here it's getting more shallow, so it's directly in the middle where it's at its steepest, and we know the maximum value of p prime is 1. So that's the steepest slope is 1. So that means that this value here must be 1. And then what else can we do? Well, we can kind of see the shape taking place here. You can see that this slope is roughly the same as this slope, but I'm supposed to be mathematically correct about it. A quadratic, well, the derivative of a cubic will always be a quadratic, and quadratics are symmetric about the center point, which is here 2, because this is the maximum value, which is 1. So that means that the other point should be down here, such that it's symmetric. And then we can just draw the graph between that. So we just kind of draw a smooth quadratic curve, connecting all the points. That wasn't very smooth. But hopefully you can do that better with your pen and paper or pencil and paper. So yeah, that's going to be the graph there.